Friji University. And after that, we have a question and answer session and closing. So today we will have two presentations, and please inform that for those who wish to ask questions, please kindly type in Q&A or chat box, and we will discuss later together in the last 30 minutes for collective Q&A session. To officially begin the e-talk, we are pleased to invite Professor Iskandar Zulkarnain Siregar, Director of the International Program at IPB University, to start his opening. Professor Iskandar Zulkarnain Siregar, time is yours.
Thank you, Dr. Shafitri. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, Jakarta time, and good morning, Brussels time. I'm only very short introduction. First of all, thank you to Free University Brussels through Professor Jonathan Chan and Professor Nicolaus to come and to give a presentation about the topics today. So I'm happy that some students are coming. Yeah, this is just an introduction. Yeah, about the VUB. So for sure that we will make another event. Yeah, since we are born in Erasmus Plus program. Yeah, through the coordination of Professor Jonathan Chan. So enjoy this evening talk from Jakarta. And good luck. I would like to officially open this event by saying Bismillahirrahmanirrahim. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. I give to Safitri again.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Professor Iskandar. Without further ado, please do allow me to read short biography of our speaker, Professor Dr. Nicholas Deligianis. He is the Associate Professor at the Electronics and Informatics Department, ETRO, at Free University Brussels, VUB. And he is also Senior Artificial Intelligence Scientist at IMEC in Belgium. And he is also the Program Director of the Master in Applied Computer Science at VUB. He is currently focused on research related to signal processing and machine learning, and also algorithm for explainable AI with application in computer vision, data mining, and natural language processing. Since 2013, he was awarded several awards such as Best Paper Award at the International Conference on Distributed Smart Cameras, and in 2013 as the Scientific Prize VWO IBM Belgium, and in 2017 he got the Eurosip Best PhD Award, and he is the Young Scientist Best Paper Award and Best Paper Award at the 2019 IEEE International Conference on Image Processing. So we are cordially inviting Professor Dr. Nicholas Deligianis for the presentation entitled Applied Computer Science at Free University Brussels. For Professor Nicholas, time is yours.
Thank you so much. Salam alaikum. Thank you so much, everyone, for the kind introduction. And I'm very pleased to be here with you. So I would also like to extend my gratitude towards the organizers of this event. It's a great pleasure to be here. And it's also, and I also want to extend my gratitude to my colleague, Jonathan Chan, who kindly introduced me to you, and this gives me the opportunity, the great opportunity to be here with you. And finally, closing, thanks to my master's student, so undergraduate student, Vitalis, who is also going to give you a description of his experience. Let's say he will share his experience with our master program. So how I would like to organize this this presentation is first to give you a small introduction to where I'm coming from, and especially what I represent, particularly the Master in Applied Computer Science at VUB. And actually, Vitalis is a master student together with that is going to share his experience. And at the same time, and later on, I will present you research work that has been produced by one of our graduates, which is Tien Hu Do. So the Master in Applied Computer Science provides challenging learning opportunities with the scope to transform students with a Bachelor in Engineering or a Bachelor in Applied Science. For instance, physics, chemistry is also a possibility, mechanical engineering, different disciplines of applied sciences into the next generation data science and data engineering experts. So that's what we actually trying to achieve. And you can see if you use a recent report by PwC regarding the most where the most hires will be and what are the most fast growing jobs and occupations in the current age, you can see that our master program is actually situated in the heart of these developments, is actually producing data scientists and data engineers, which are the most which are the most fast growing occupations currently in the international market. And you can see that again from the same report, we have also taken what are the most important qualifications that such graduates should be able to have. And you can see still that courses that we are and let's say skills that we are covering are very well located in our master program, and they are in the let's say state of the art. So skills like machine learning, analytical approaches, engineering, including hardware, software, and storage of data, but also data governance and visualizations. These are fields that we are greatly covering in our master program. So just a very simple slide that tells you that actually all these skills are required for the data scientists of the future. So you need to know math, you need to know statistics. This covers areas like machine learning, statistical modeling, and Bayesian inference. You also need to have a very strong background in programming and databases and scripting languages, and for instance, Python, but as well as databases, languages like SQL or NoSQL are fundamental for this kind of new domain. At the same time, a modern data scientist should also build soft skills, should be able to communicate, should be with other members of the team, should be of course a team player, should be a problem solver, but also should have an innovative and hacker, let's say, mindset. And of course, such a data science should be able to say the story behind the data, should be able to visualize the data, should be able to let's say to compress the data and to be able to present them in a very coherent way. So the master that I am directing actually covers these areas, and in fact covers the entire span of the data science discipline. It actually covers areas like hardware technologies and design, including sensors, actuators, and electronic and photonic components. It covers advanced networking, Internet of Things systems. It covers AI and for data processing and data analysis, and machine learning, of course, but also data governance, including databases, systems, and distributed computing. We have three main specializations in our program. One is smart cities, where students learn about how this kind of principles can be used to solve logistics, mobility, and IoT related problems for creating the next generation smart cities. We also have a module on digital health, which is focusing on e-health, connected care, but also medicine and biology, for instance, in order to tackle computational intelligence problem in this area, to tackle problems using a computational intelligence, let's say, lenses. It's important, for instance, to also mention the third dimension of our program, which is Digital Earth. And Digital Earth tries to solve problems related to climate, water resources, quality of air, using artificial intelligence techniques. And we are also very happy to have Jonathan being a key player in that, in this, let's say, branch of our master program. And finally, what we have also established is a double master's degree or with the Technical University of Cluj-Napoca in Romania, a very well-established university in Eastern Europe, a very, very good technical university as well. And there the focus is on data science for business intelligence. So should you decide to follow such a master's degree, then from the VUB, you get one of the above 3 specializations. And from the Technical University of Cluj-Napoca, you get the business intelligence specialization. It's also very important to mention that master theses are covered in all of these topics, and all these master theses and research theses have actually addressed interesting problems in the society. For instance, you will see later on a research that we have done in the context of smart cities, which solves the problem of air pollution in cities, or problems related to social media analysis, where we solve problems related to, for instance, fake news. You will see, I mean, you can also see my publications record, where you see that recent publications from our graduates related to analysis of social media for COVID-19 event detection. Or you can see, of course, the publications of Jonathan and other colleagues related to Digital Earth and how you can use remote sensing technologies and AI technologies to solve important problems related to Earth and the environment. This is how our program is structured. We have the first year 42 ECTS on operating systems and security. We cover courses like operating systems and security, scripting languages, IT networks, advanced programming concepts, computer science systems, as well as databases and AI. And then the students get to select one of the specializations. So one specialization is, so the smart cities consist of mobility courses, embedded systems, wireless sensor networks. The digital health, relates to data analytics in healthcare, biomedical systems, and so on and so forth. But also the Digital Earth module, which contains courses like climate and land and climate dynamics, water management, and GIS systems. And then in the second year, we have a number of compulsory courses, including deep learning and distributed computing, and as well as soft skills for computer scientists, which are courses that I teach, but also technology of microelectronics and photonics. Then the students get to select a master thesis, and they cover 3 CTS from their specialization. Of course, we have the possibility to follow a number of ECTSs into an internship or a module on entrepreneurship. So you can see here the links to the corresponding departments. I'm happy also to share the presentation to see, to be able to follow the links. You will see that we have established a lot of partners from the industry. These are partners for which we have established joint projects, for which our graduates have interned, for which our graduates have been hired, and so on and so forth. But we also have a lot of academic partners. We have joint research labs with Duke University in the US, with University College London, with EPFL in Switzerland, with the University of Patras in Greece, with the University of Cluj-Napoca. We have a double degree. We organize a lot of interactions with the industry. For instance, this is an example of a data challenge that we created in 2017 in collaboration with a big advertisement company called MEC, which is now called Wavemaker. So they organized a data challenge for our students and students of our program, and as well as students of University College London, and they compete for a prize, which actually led to very nice results and international collaboration. We also had the opportunity to host very prestigious people in our university, including colleagues like Professor Robert Kalterbank, who was in 2018 an international Frankie chair on big data. So he had a visiting chair to provide, let's say, research, supporting research, and he also provided invited talks for 6 months. We also have a very strong connection with our alumni. We have a LinkedIn page where all our graduates are at least in the very recent years, are participating, and we share a lot of messages, and we share a lot of opportunities, including openings, including experiences, including opportunities, and so on and so forth. You will see here some testimonials, and these testimonials are also available on our website. Then I will go to the explanation of the research. So first, I would like to invite maybe Vitalis to give his testimonial, and then I will basically focus on the research part. This is the website where you can go and basically, if you can just Google Max VUB, then you will see the website, and you will actually be able to navigate across the tabs. You will see the program. You will be able to see information about the thesis and internships. You will be able to see information about the research that is related to the program, and you will see opportunities about what happens after graduation, but as well as admission criteria. So what are the admission criteria for the program? What is the requirements to be admitted? What is the fees for our program? Here to mention that the fees are significantly lower compared to other universities in Europe and in the UK. In general, a non-European Union student will not have to pay more than 3,500 euros per year for tuition, which is dramatically lower than other universities in the vicinity. And of course, you will be able to see practical information regarding, for instance, opportunities to fund your studies, and as well as other opportunities where to find us, as well as how to contact us. So if you're interested to follow our master program, then you just visit the website. You can just Google Max VUB, and you will navigate through the website. And don't forget that if you are interested to apply, then you should do that before the 1st of April, where we have the opportunity for the non-European Union citizens. So with that, I would like to give the floor to Vitalis, my graduate student, well, undergraduate student, who is now working, who has been working with me for quite some time as a job student related to projects that we have in fake news detection. So Vitalis will be able to explain also that he was actually integrated into research. And he's also my master thesis student currently related to natural language processing. So maybe I can give the floor to Vitalis if you agree, Safitri.
Sure, Prof. Nichols. Please, Vitalis, you can just present your presentation. If I'm not mistaken, the title is Graph Deep Learning for Smart City and Social Media Data Analytics.
This
So,
is a presentation that I will give. No problem. I mean, Vitalis
okay.
can show you can share his experience
Okay.
about the program.
Okay. Please, Vitalis.
Yes, thank you. Hello, everyone. My name is Vitalis, and currently I'm a second-year master's student in applied computer science at the VUB. I would like to share with you my story of how I've joined VUB Max and my overall experience in this master's. So after finishing my bachelor's in computer science back home, I had a will to further deepen my knowledge and expertise in the computer science field, and additionally to get some experience participating in diverse international groups. So upon open research, I realized that VB seemed to be just the right place for it. So first of all, what I really liked about this program is that while developing some fundamental computer science basis, we're all able to specialize in specific domains of our interest. For example, I'm in smart cities specialization, where we have extra focus on Internet of Things, mobility, and logistics for finding sustainable solutions for environmental problems. Furthermore, due to my interest in big data and artificial intelligence, I was able to take a lot of courses in this area as well to deepen my knowledge. Overall, flexibility in choice and a mixture of theoretical and practical sessions create an exceptionally inspiring and probably stimulating environment, which I truly enjoyed and still enjoying. And secondly, in this master's, what should be mentioned is that a lot of time is dedicated to group projects. So in such a way, we are able to learn how to work with other people, how to manage workflow, how to share responsibilities. And overall, working in diverse groups where each member has a different background is a very interesting experience because you really can learn a lot of new stuff from people who have different knowledge. So overall, Max helped me to grow as a specialist, probably to understand better the industry. It gave me not only theoretical knowledge, but as well some hands-on experience with the cutting-edge technologies. So overall, I can tell that I've gained knowledge, confidence, and practical skills that are already helping and will help me in the future with my work. And in a nutshell, I would recommend this program to anyone who's passionate about the computer science field. It is definitely challenging, but you will enjoy it.
Vitalis, it might be a good idea to maybe highlight that despite the fact that you are a second-year master student, you have been participating in as a co-author in international patent.
That's true. That's true. As well, what should be mentioned, like really an ability to integrate into the industry. While being a second-year student, I was able to take a student job and participate in really great projects on the fake news detection. So really big global projects, and in such a way, while being a student, you already have an ability to be already like a part of an industry. So like after graduating, it's not like you're starting everything from the scratch in the workflow, but already you have such a combination while being a student, and that is really a great opportunity, in my opinion.
Okay, thank you, Vitalis. I think from his testimony, we can see that the master degree in Frigi University is very interesting. You can have a lot of experience there, and also you can also get the opportunity to enhance your career even in the practical or industry. Thank you, Vitalis. Prof. Nichols, you can continue your presentation.
Yes, I don't know whether there is any question with respect to what has been mentioned before, or you want to keep time for questions at the end. How would you like to?
Okay, we can collect the question maybe the 30 minutes before end of the talk.
Okay, great. Then I will be sharing the second slide set. Can you see that?
Yes.
Okay. Okay, so this is the presentation that I would like to give, and this presentation is about graph-based deep learning or deep learning on graphs for social media and smart city data analysis. And here I would like to extend a big thanks to my current postdoc and previous PhD student, Tien-Hu Do, who actually is the person that conducted this research. And this research actually resulted into his PhD degree. And actually most of the information that you will be seeing here is actually created by Tien, and including this slide. So a big thanks to Tien, and this actually shows you the quality of work that our graduates are able to produce. This is the story behind the research that Tien has been doing. First, you will see that currently we have a lot of information that flows in on the internet per minute. For instance, you in 2020 you have 400,000 hours of video streamed by users on Netflix. You have 2,700 app installations. You have 319 new users gained on Twitter, and so on and so forth. So we are talking about the age of data deluge. We are talking about the fact that data is now everywhere, especially in fields like smart cities, in fields like the internet, like social media, and so on and so forth. And the question that Tien has addressed in his research is how can we basically tackle this kind of problems. So Tien focused and our research focused on graph deep learning, which finds a lot of applications in social networks, in analyzing brain connectivity, in transportation networks, in sensor networks, and in networks of, for instance, users and authors, and how they connect to in terms of citations, but also the analysis of, for instance, data like world airport networks. The big data has a lot of specific characteristics. It's the 5 V's, as we call them. And this is veracity, value, volume, velocity, and variety. Data is changing rapidly. That's the velocity. Data is huge. So we have the challenge of storing it and processing it and retrieving it. That's the challenge related to volume. There is also the challenge related to variety. So data is very much heterogeneous. So we have different types of data, and the question is how can we extract information from such diverse types of data. There is also the challenge of veracity, the fact that data is noisy and it's incomplete, and therefore it's very difficult to extract knowledge without specific algorithms. And the big question, the big challenge is related to value. How can you use data to extract value, to extract knowledge? How can you efficiently leverage data for a certain goal? So currently in the field of AI, the neural networks have been let's say the cradle of techniques for the processing and the analysis of data. And neural networks are called like that because in the past, at least, it was believed that there is, like, let's say connectivity. There is an analogy with the neuron, the neuron in the human brain. So the neural networks are a bunch of neurons, let's say. Each neuron has a number of synapses, connections. And in the body of the cell, you are doing a projection of the weights with the data that they're coming as input into the cell of the perceptron, the cell of body, and then you add the bias term, and you apply a nonlinearity to get the result of the neuron. And if you stack a lot of such neurons together, you can create a very simple neural network, a linear neural network. And if you stack many layers, if you stack a lot of intermediate layers, then you actually have a deep neural network, a network which contains a lot of layers. Now, what is a graph-based neural network? A graph-based neural network is inputting data that they have specific structure, and that's what we call a graph structure. So in a graph, you have nodes, and you also have connections, edges. So an edge connects two nodes. Each of these nodes has also a number of attributes, a number of features. And the network is basically having a certain structure, which is then encoded with, for instance, the graph Laplacian, and is used as input into a neural network. So then the neural network, what it does is that it performs processing on top of this graph-based structure. So it performs convolutions, but now these convolutions respect the graph-based structure to produce a result. So that's the difference in graph neural networks. So what has been the contributions of this research? First, in the field of social media data analytics, we have created a method that is based on multi-view and graph deep learning to predict the location of users. For instance, in case of a disaster or in case of marketing, you need this kind of information. This graph deep learning method has also been used for detecting fake news on social media. And the second contribution relates to applying graph deep learning for smart city analytics. And there, what we have proposed is a graph autoencoder for denoising graph-based data. And we have also proposed a variational graph autoencoder for air quality inference. And finally, what we have also proposed is, let's say, a more fundamental contribution where we have developed a new regularization technique and a new message passing scheme for graph neural networks. So let me go into each of these contributions. So first, related to social media data analytics. An important problem in social networks, like for instance Twitter, is to trying to predict the location of a user. So you see here on the left some profiles where you do not have information about the location of the user, and also profiles on the right where you have information about the location of the user. The information, however, is very much broad, is very coarse, and we would like to have a finer information so as to be able to provide, let's say, services related to crisis management, to know, for instance, where people are and how they move when there is a crisis, including COVID-19. Or if you want to do advertisements, for instance, or if you want to do high-level analytics for for marketing. So the question is whether we can take as input a lot of information from social networks, including the connection of users, including text, including the graph of the user, and input this information into a machine learning model, which has been trained using label data. So basically using social media posts that they are geolocated, or for which, for instance, the users allow this the location of the tweet, and to predict, for instance, the location. The location can be either in areas, for instance, either in the east or the south or the west of the United States, or it can be even at the state level or at city level. Or we can even try to predict the exact geo-coordinates of the user. Let's see how we have addressed this problem. The first thing that we did was to realize that the fact that we have social media users on the web, the fact that we have users that interact with each other on social media, this can allow us to create a graph of users. So you can see, for instance, here an example where user 1 and user 3 both mention user X in their posts. So and the fact that user user 1 and user 3 both mention user X, then this creates a connection. In the same way, between user 1 and user 3. In the same way, user 4 mentions user 3 and user 3 and user 1 in his or her tweet, and this also creates a connection between them. So based on the mentioning, or based on information like retweet or sharing of information, then or commenting, then you are able to create this kind of graph structure for social media users. And the question is, how can you use this social graph structure in neural networks? Here we have proposed a network which is called MNet. So the network takes as input diverse features from the information. So we take input from the tweet themselves. For instance, we take a representation related to bag of words. We can also take the tweet and convert it into a textual representation using, for instance, Node2Vec, the Doc2Vec features. We also consider the how the users are, the graph of users, and for that we input the graph into a representation which is called a representation learning method, which is called Node2Vec, which you give as input a graph, and the Node2Vec creates a representation, a vector which represents the node with respect to the graph structure and the other nodes. And then we also provided the timestamp of the tweet. Now, all of this information is encoded into vectors and then provided into a linear neural network, which is then predicting with a softmax classifier at the end, predicts either the probability of the class or where the class is a certain, let's say, state in the United States or country in Europe. Or it is also trained to predict exact geo-coordinates. So the first problem is a classification problem. The second problem is a regression problem. However, the regression problem, we are actually solving it as classification. So what we do is we observe that it's very difficult if you want to localize a person on Earth to predict the exact geo-coordinates. But instead, what we are trying to do is to take the Earth, quantize it using, for instance, a multi-resolution quantizer, and then which basically learns, it's basically like a Max Lloyd quantizer, where we take as input the probability, the histogram of trees in different locations, and then we train a Max Lloyd quantizer. And then we learn to predict on in which quantization cell a user resides. And then the location of the user is predicted as, for instance, the centroid of the area that he or she resides. And for this quantizer, let's say, we use the S2 partitioning that it has been provided by Google. You can see here on this slide the performance of our network compared to other techniques in the literature, and the information is of course available in the reference section that you will see here. And the you can see that our method has achieved state-of-the-art accuracy in various data sets and against various techniques. Here you see, for instance, that how do we compare in the state and region classification, and also how do we compare in the exact geocoordinates prediction. And with bold, you see that we are outperforming the other techniques, and with non-available, basically, you see that this information has not been provided by the users of the corresponding papers. So that's the first contribution. The second contribution relates to how to predict fake news on social media users and social media using graph deep learning. The problem of fake news detection is very important, and has actually led to a lot of problems in our society. So the question is, how do we address this problem coherently? So the what we did to address the problem of fake news, we actually emphasized that information that certain articles, let's say, that tend to be published by publishers may be fake. And of course, when a user, let's say, retweets, or when a user posts fake information, then they tend to basically do, if they are planning, if they are actually users that they share fake news, they typically do that in some coordinated manner. So basically, they tend to always, let's say, distribute information from the same or connected sources. So the question is to be able to classify articles as fake or true, given the interaction between publishers of information, articles, and social media users. So we thought that articles from the same publisher tend to have similar credibility levels, and users who share unverified news is likely to share the similar type of news again. So these are the kind of, let's say, hypotheses that we did. And then what we did was to construct a graph method for these kind of articles. So we created a graph approach, where in the GraphNet, the node represents articles, and the nodes, the articles therefore, are connected if they're published by the same publisher or if they have common users. And then each node feature is a word2vec feature. And then basically what we do is that we input this structure into a graph deep learning, where in our database we have only labels for some of these publishers. And the neural network is learned to predict the labels for the rest of the publishers. So it's basically, you can see this as a semi-supervised node classification problem, or as a label propagation problem, if you wish. And we use there the the graph neural network by Kipf and Welling. And of course, as you can see here, we got state-of-the-art results with our method in various data sets, including the BuzzFeed and the PolitiFact network. And actually, this paper has resulted into the one of the best paper awards at the NATO workshop. So here, this is our work on graph deep learning for traffic data analysis. What we did was to try to denoise data, traffic data. So in cities you have devices that they measure the traffic in certain locations. This information, however, because of failure of hardware and software, because of course of other external factors, the measurements that you have is typically noisy. So the question is, can we create a deep neural network that denoises data, takes this data that live on graph? So you take as input the graph data, which is noisy, and the graph neural network is outputting a noiseless or denoised, let's say, data. It's trained, therefore, to predict a denoised version of your signal. So you see here the graph structure of the traffic data. You see that every node represents sensor locations, and the connection between nodes represent geodesic distance, and the feature, let's say, at each node is a vehicle speed. And instead of the actual true data, which are represented by blue, our measurements are contaminated by additive noise, by white additive noise, as you can see here on this slide, where it gives you the model that we are using. So instead of the blue values of the blue values of our signal, we actually observe the red values in our signal, which is our signal contaminated by Gaussian noise. And the signal lives on a graph. So the question is whether we can use this graph structure to denoise and to provide the ground truth data. So for that, we have proposed a graph signal denoiser using a graph autoencoder. The graph autoencoder takes as input the graph signal and outputs a graph signal as well. And our autoencoder is as follows. So you take the noisy signal, you perform graph convolutional, you have a series of graph convolutional filters, and then you have a cron pooling operator, where the cron pooling operator is basically pulling the graph, so it's making the graph smaller. Then on top of this graph pooling, you do some fully connected processing with fully connected layers. And then what you do is an unpooling operator, because you are interested to do an autoencoder. So when you downsample your graph, you need to upsample it back, and that's the unpooling operation. Then you perform a number of graph convolutional layers, and at the end you get your output. And so you can see that this is, let's say, a version of the UNet, right? I mean, or let's say an autoencoder, a hourglass autoencoder for graphs. The cron reduction, the cron pooling reduction, the cron reduction based pooling is a method to simplify a graph while at the same time maintain the harmonic solution. So if you have a graph with V nodes and epsilon edges, and then you can create the graph Laplacian, and then your cron reduction is basically creating a new version of the graph Laplacian, where it's basically preserving the harmonic solution. So you can see more information into the related ICASP paper. And here you see the result of our methods, where we are actually compared our proposed system with a Gaussian filter, with another graph convolutional neural network, as well as a graph filter, and you can see that we systematically outperform the state of the art for different kind of methods in the task of graph signal denoising, where we used actually a realistic data set from the Seattle loop data, to perform our experiments. So this is another type of work that we are conducting together with IMEC. So what we are interested in IMEC is to be able to predict the the air pollution at the city level, and actually at the micro location level on the street, and with a very few meters accuracy. Currently, the method to predict and to measure air pollution relates to the following. You have a number of fixed stations in the city. So you see here, for instance, in the city of Antwerp, we have 6 such stations. These stations, they measure pollution accurately. They have very expensive instruments to do that. But of course, you only have 6 of them. And then you're using interpolation techniques to try to predict the pollution in the rest of the city. However, the city is really a very complex ecosystem. Every street can have a completely different pollution level at a certain time instance compared to another street in another time instant or in the same time instant. So the question is, how can we measure realistically and very accurately in a very, very small quantum of time, in a very small quantum of space, the pollution? And there what we propose is, we propose to place sensors on top of moving vehicles, and at the same time to use AI, advanced analytics, which I will show you. This is our role in the project, to predict accurately the pollution. So basically, what we did was to observe that data that live in the street, let's say, network, they form a graph, and this graph is basically connected. You create the edges of the graph by using by the fact that whether the 2 locations are close to each other or they are on the same street segment, and then you have this kind of graphs across time. And the question is to create because you are interested in from few measurements to predict all the measurements as if you would have them, but of course you don't have them. So it's basically, you can see this as a matrix completion problem, where every column in this matrix signifies the measurements and at different locations for the same time instant. So this matrix is highly sparse, as you can imagine. With question mark, you can see the locations in time that they are not measured. So for instance, in the first row, you can see that there is a measurement, but there is in a certain time instant, but only after 2 more time instances, we have another measurement. Or there are locations like the light gray row in the middle of the matrix that they remain completely unmeasured. So the question is, how can we, using these measurements that we have, how can we fill in the rest of the matrix? And for that, we have proposed a variational graph autoencoder that takes as input the measurements as well as the the geocoordinates of the location, you perform a number of graph convolutional layers. You learn the statistics of the data, and from the statistics of the data, you have a decoder which learns to generate your data from the measurements. And you can see here, for instance, the filled-in information, where the method is supervised basically on using the locations for which you know. And you can see here the loss function that we have created for training this neural network. So this research has also been extended to take into account the correlation with the different matrices. So you don't have only one matrix, but you have different matrices because you have different pollution, different pollutants that you're measuring. You're measuring CO2, you're measuring NO, and so on and so forth. So by taking this advantage of this correlation, you can see that you can further improve the accuracy. So here we compared against various approaches relate to interpolation methods that used in environmental engineering, like exponential kriging. We used also we compared against collaborative filtering methods like matrix completion methods like SVD, matrix factorization, but also deep learning methods like a CNN autoencoder. And you can see that our approach dramatically outperforms the state of the art. And here you can see, for instance, a visualization of the city. So this is the actual data from the city of Antwerp. On the left, you see the locations that they're measured, and with color, you see the level of the pollutant with color coded. And on the right, you see the predicted pollution in the different locations. So you can see that with very few data, we are able to infer the pollution at a street segment with very high granularity and very high accuracy. And this work is also continued, of course, has resulted in a lot of publications, including an IEEE Internet of Things journal paper. So before I close the talk, I just wanted to share with you also some recent results that they are already published into the Elsevier Journal of Expert Systems with Applications. And this is basically new techniques on how to improve the message passing in graph neural networks, as well as to perform graph regularization using the drop node technique. So there are several techniques that you can propose message passing in when you perform the convolution in a graph deep learning. So you can see the most generic formulation with equation 1, but you can see the one proposed by Kip et al. In the graph convolutional neural network, which is given by 2. You can see also the one proposed by Zhang et al. And what we actually proposed is another method to perform message passing, which actually has the advantage that leads to better feature weighting for the nodes that they are closer to a certain node in the graph. So this of course has specific advantages when you come to do graph deep learning, because you want to increase, let's say, the influence of nodes that they are closer to you. And another thing that we have proposed is a method to perform regularizations on graphs. And this method relates to addressing overfitting, of course, and also addresses oversmoothing. Because graph deep learning has also been, let's say, accused of oversmoothing. So the idea is basically to randomly drop nodes during the training of the neural network. Similar ideas have also been presented by recently by other researchers, but our technique has also been incorporated into this approach. So here you can see how the method works. So you basically have a neural network. You have a number of graph convolutional layers. Then you perform a downsampling by means of the drop nodes. So you drop randomly with a certain probability some nodes from the graph. Then you apply graph deep learning on the reduced graph. And then you're applying upsampling by basically adding 0 vectors for nodes removed. And then after a number of graph convolutional layers, you can address the problem that you're interested in. And you can address problems related to, for instance, node classification, where you're interested in learning what's the label of every node in your graph, or even graph classification, where at the end you're interested in classifying the entire graph. So this is also something that you can do. And here you can see that our methods actually dramatically outperform the state of the art. For different approaches and different data sets, we are outperforming, we produce better results in graph deep learning. So to conclude, we have worked on graph-based deep learning models for classification. We have proposed a graph autoencoder for graph signal denoising. We have proposed a variational graph autoencoder for matrix completion on graphs, and as well as a new message passing scheme and a regularization method for graph deep learning. And the future work of Tien and other people in the group focus mostly on interpretability and explainability of this kind of methods, because graph neural networks are notorious for being, together with other deep learning approach, of course, for being black boxes. So it's very difficult for a user to know very well what the method predicts and why. And here you can see some of the general publications that we created during this PhD. There is a third one as well, the expert systems and applications, which is very recently accepted. And a number of conference papers in very good venues, such as ICASP, such as NACO, as well as conferences like IEEE Sensors. So that will be the end of my presentation. I would like to thank you for your attention and to invite your questions.
Thank you, Professor Nikos, for the very informative presentation. Wow, how useful big data analytics, especially for in this era, as we know that many millions of people are using social media, and also currently the data is everywhere. And Prof. Nikos, we are now in the question and answer session. Pak Dasa, maybe you can help me to collect the question. Is there any question?
At the moment, not yet. Perhaps can we directly open the microphone to the participant?
The participant. Okay, so please, for the participant, if you have any question, you can just open your mic and raise your question. So
perhaps I would like to ask the questions in regard to
Pak Dasa.
in regard to the scholarship and program fee and how to live, for example, in Belgium compared to other city. Is there any possibility, for example, for our students in IPB, because in IPB has also computer science or also statistic and data science as well. Nowadays, there are also a new program in IPB for statistic and data science. Is there any possibility also to continue at VUB to apply for the scholarships, and also the, for example, Erasmus Mundus scholarship is if there is available?
Absolutely, absolutely. We have we of course have a number of scholarship programs. Maybe I can show you my screen. Yeah. So here, if you navigate into our website, and if you go to the tab practical info, so this is the website, this is the first, and then if you go to practical info, you will see the different scholarship for individuals, for individual students. So you can see priority countries programs, you can see the ASEM Duo scholarships, and you can also see the mastermind scholarships. So this information is provided. And we also have a lot of internationalization experts in our university, and they are very well aware of all the different schemes that the students can apply. And there are many of them. So if you are interested in that, I would be happy to follow up on this with our internationalization experts. And of course, Erasmus Mundus, an opportunity of creating new proposals is of course something that we are very interested in. And Jonathan, of course, has been proven very, very successful in this kind of scheme. So I would rely on his experience.
Okay, thank you very much.
Thank you very much, Prof. Nikos. Pak Dasa, do you still have a more question?
No, perhaps thank you.
Okay, you are welcome. Okay, please, for the attendees, you can just drop your question on the Q&A box or chat, or also you can directly raise your hand, and then you can open your mic to raise your question. Maybe while waiting for the next question, we have also Professor Jonathan Chan. Professor Jonathan Chan, are you in? Okay.
Yes, I'm here.
Okay, maybe you can give your sharing in the experience of your research here.
Okay. I was not preparing to do a presentation, but I do have some. Maybe I can share a little bit. Wait a second. Can I share my screen?
Yes.
Maybe Prof. Nikos can stop your screen first, or the host.
Yes, I don't think that. Do I need to stop sharing my screen?
Maybe not necessary, I think. How do I?
Okay, I'll stop sharing. Okay. Does this work now?
You can open. Okay.
Do you see my screen?
Yeah.
Yes.
Okay. Well, I can briefly talk about my my research. This is something related to another Erasmus training that we provide to Asian partner. Okay, there's some problem. Okay. My specialty is related to using space technology and probably a lot of you doing agriculture, you understand the use of satellite image to do a lot of monitoring. But for agriculture, of course, this is one specialized field. And my background is also focusing on the use of hyperspectral data, which is a little bit more information in the spectral dimension. This is just some possibility using remote sensing to do agriculture monitoring in terms of monitoring the crop production, using temporal data, assessment of crop damage and crop progress, using single date or temporal data, identification of different crops, the crop average estimation, crop condition assessment, and stress detection. So these are all related to what we can call some kind of a smart agriculture, to have a good estimation of your harvest or deal with the disease before it spread. I will really jump. I'm not going to do the very detailed. Other application in terms of disease infestation, moisture estimation, soil mapping, crop nutrient deficiency detection, and determination of the water content in your agriculture or crop field. So there are 2D, 3D estimation. Normally we use remote sensing data. In this case, this is actually some monitoring in terms of thick wood forest using very high resolution UAV data. And then we were comparing with some satellite data in the 0.6 meter resolution. Compared with aerial photo, we can go to 5 centimeters resolution. So these are some estimation using a 3D reconstruction, so that you do not only have a mapping in 2D, but also using 3D reconstruction to measure the height. And this is you can calculate the volume of your product or your field. And the other is some more detailed or accurate delineation of the parcel, actually the boundary of your fields for measurement. This is one example of actually counting the number of stands in the plantation. So now the data is fine enough to actually counting the number of trees for some kind of monitoring. This is just one example of using orthophoto at very high definition, and then using reconstruction to have a 3D model to do it. Now, if we are now having a project with IPB in terms of a curriculum development, and then I think in the near future, once we can meet, we will provide a certain technical training. And then we will really do the practical and the theory part we were given I think in a number of weeks, and then the practical part that we hope that we will come to Indonesia and then provide the practical training. There are other applications. For example, this is one way, actually just using the color of your field to actually understand the fertility of your rice plant. And actually you have a lot of coloring, and then depending on the color, and then you can give an index, and then afterwards with estimation of your harvest. And this is actually it's done by your university. This work. Going to the part of my specialty is hyperspectral imaging, that is providing a much more spectral information and a more detailed characterization in terms of vegetation. So I would jump to so these are some possibility using now the more novel spaceborne mission to have a very detailed mapping of a different kind of vegetation. So these are a comparison of a multispectral dimension, like what you have with a Landsat or with a Sentinel-2 mission from the European Space Agency. And now we are able to measure the full spectrum from, for example, like a 400 to 2,500 nanometer with more than 200 bands. So we can have a much more detailed characterization in the spectral dimension of vegetation. So these are just a comparison with a field measurement. What you see is in red color. That is the field measurement with a field spectrometer. Perhaps some of your colleagues will have this experience. And then you can see the absorption window in about 1400 and 1900. Those are with moisture or absorption window. That's why it is very noisy. In comparison with some of the state-of-the-art hyperspectral satellite data. So this is comparison or validation of the satellite measurement. So these are just some physics in terms of how we are using electromagnetic radiation, their reaction with a plant and the leaf surface, why we can develop this principle and the theory applied to agriculture assessment. So more into the assessment of the quality of the vegetation in terms of chlorophyll A and B. That is the advantage of using hyperspectral data. And then you can see that using this chlorophyll content, we are able to see using the spectral information. We are actually can measure the cycle of a plant. Okay, for very green or when then the chlorophyll drop, and then you can see the difference with a different life cycle in the course of the time span of vegetation or plants. The other, of course, very important is disease detection. Remote sensing has been used for early warning of if you have some problem or some spread distribution of a disease in the in your cultivation. This is one example of using an unmanned aviation system or vehicle using hyperspectral data to have an early detection of plant disease. And maybe this would be more interesting for your university. This is just some impression of the study area, and then also the data that acquired in the field to do this kind of a disease monitoring. Well, there are also the many possibility. There are new way of understanding using simple indexes. So before we see that in agriculture application, we have developed many because agriculture is such an important topic. So in remote sensing, there are a lot of different kind of index to help us for monitoring. There are quite a number of them. But you can see that they are specified in terms of a special wavelength, okay? But these are variables. So actually, we can fine tune it and using a more focused or more informative spectral bands in order to achieve a better result. And hyperspectral data will give us a much more diverse and more opportunities to do that. And this is a kind of a feature selection model. We are using the feature analysis from Purdue University in Indiana. So these kind of methods are more state-of-the-art, but in terms of the application in real agriculture scenario, it is still quite new. There are quite a lot of potential to further develop. This is just other rather lab-based analysis to fine-tune our monitoring of the quality of the plant in the full spectrum with a different scenario, different illumination, different sunlight, and different radiation to understand how we can monitor better in terms of the if the plant is having a stress, because of drought without the adequate irrigation. So these are just a very detailed monitoring in the laboratory. This one is in the laboratory, rather in the field, to monitor within a certain wavelength, which narrow bands will be the best to use for the index generation. This is a recent collaboration with our colleagues. So with Erasmus capacity building project, we are able to help them to create a new laboratory. And then they have the equipment with the new drones and also the equipment and software. And with the technical training we provide, they start to monitor their cultivation using very, very simple remote sensing approach. With a UAV, they will get a multispectral image. For example, here you have the visible and also the infrared. And just with a visible infrared, you are able to generate some kind of index to measure the biomass in your field. Okay, so this is a false color composite. That means we are using the infrared to represent in the red channel in your screen. So the redder you see means that the higher the biomass. So if you have a very, very low value in the infrared, that means you probably will have a drought or some kind of irrigation issues. So then you can treat with additional measure. But at the same time, you can also identify whether the plant is growing normally, and then you can somehow use a more efficient dose of the pesticide. Okay, so it's always linked to the Internet of Things and also the way of using the minimum of a fertilizer and pesticide, so that is more environmental friendly. And we are having another new project as a continuation, specifically to apply the remote sensing technology in agriculture in the future. So these are some different kind of index you can use in combination in order to assess the growing or in your cultivation. Yeah, so this is very, very brief in terms of the research in Earth observation. But of course, I think we are just in the beginning with IPB, and we look forward to more communication in the future.
Thank you, Prof. Jonathan. I remember that IPB currently focusing on also in smart agriculture and also smart forestry. We are working with monitoring in the wildlife conservation, especially in the Sumatran tiger and also orang utan. So thank you, Prof. Jonathan. Okay, Pak. Maybe it has been 4 o'clock, and I think Prof. Nikos can't wait for longer. So if there
Nikos,
is no
before you go,
question from the...
Well, I just want to say thank you for...
Prof. Jonathan?
Yeah, I just want to say thank you for Nikos for this very nice presentation today.
Thank you, Prof. Jonathan.
All right. It's a pleasure. Thank you so much.
Okay, so I think that's all from 15th EIPB talk today. Thank you so much for Professor Nikos, Professor Jonathan, and also Vitalis for your valuable sharing today. I hope we huge information, and we can continue our collaboration even outside or after this meeting. So please don't forget to fill out the attendance form to get the certificate. Thank you so much for your participation on this event. Hopefully we would be beneficial for us and further collaboration between IPB University and also Brussels. We encourage you all could engage each other after this event. Thank you so much and see you.
Thank you. See you. Have a nice day.
Thank you very much.
Thank you very much.